And welcome back. All right, so we just got done talking about sine, cosine, and inverse sine, inverse cosine, inverse tangent. And all of these work on right triangles. And the question comes up, well, can I use this sine and cosine business on anything but a right triangle? And the answer is yes. And that's what we're going to be spending the next couple of about a week on. We're going to talk about the law of sines and the law of cosines. And this lecture is going to talk about the law of sines and figure out what to do. So here we go. So today we're going to talk about using the law of sines in mathematical and real-world problems. Mainly mathematical. The real-world stuff is only like 2 problems. And you're also going to explain the law of sines is used to find all sides of a triangle. Not only all sides, but also all angles. So what is the law of sines? Glad you asked. Okay, the law of sines is used for an oblique triangle where none of the angles are a right triangle. That's going to be a triangle just like this. And the law of sines says this. It says for any triangle with sides, little sides A, B, and C, and opposite angles, capital A, capital B, capital C, respectively, sine A, B, C, okay. Sine of A over A is equal to sine of B over B equal to sine of C. What does that mean? It means if I have a triangle like this, oblique, none of the angles are right angles, and I come over here and I say, this is angle A, this is little a. It's directly across from it. If this is going to be angle B, guess where angle side B is going to be? Side B is over here. And if this is angle C, this is little c over here. And what the law of sines says, if I take the sine of big A up here and divide by A, it's going to be the same as sine B divided by B. And that's holy cow. And sine of C here divided by this C is going to all be the same, every single one of them. Wow. Well, that's amazing. So can I use the law of sines on everything? Okay, well, it depends on what the problem gives you. Each problem is going to be a little bit different. They're going to give you different things. And if a problem gives you either 2 angles and a side, where the side is included in between, much like here, they give you an angle here, and a side, then yes, you can use the law of sines. Or if they give you an angle here on this side, an angle here, and then a side later, you can use the law of sines. Or if they give an angle here, and this side here, and this side here, even though that spells a bad word, you can use the law of sines. But what does the law of sines hand you to help you find? It helps you find the missing angles and the missing sides. That's what it helps you find. So let's go see how this works. Okay. Some other useful things to know about is that they just, all that was done is they broke this down. Obviously this is true because that's the first 2 things. Okay, that's just true because it takes the first one and the last one. And of course this is true, it takes the middle one and the last one. Just separates it out, makes it perfectly clear. And the last thing we can't remember is there are 180 degrees in a triangle. Okay, so here we go. They give us a triangle. They say solve the triangle. When they say solve the triangle, it means find the missing angle and find the other 2 sides. Okay. So again, I take a look. I draw this triangle out. It's already sitting here drawn for you. And I take a notice of what they gave me. They gave me an angle, and a side over here. So they gave me 2 angles and a side. Because I have 2 angles and a side given to me, I know that I can use the law of sines. And so what I do is I take my information, I set it up, and I find out, well, what do I need to know? What do I need to know or find out, excuse me, is I need to know what C is. I need to find out what little b is and what little c is. Those are the 3 missing pieces of information. And so how do I know what's what? So I take the 2 pieces I already know. I know this 40 goes with this 4. And I say, well, the sine of 40 goes over 4. And I want to set that up and find out, or set up an equation to find out the next one. Let's do B. Since I already have B here, I want to find out B because I already know this angle here. Okay? So B, sine of B is 60 over B. And now all of a sudden, look what I can do. I can do back to cross multiply and divide. So 4 times sine of 60 divided by sine of 40 is going to give me my answer of B. And that's going to be, we get the magic calculator, equal to 5.389. Cool. There's B. Alright, so I get that all checked off. So I'll put that in there. 5.389. Great. So I'm going to start off doing the next one. Now, my thing is technically, you know, I always use the same information I was already given that's the exact information. B is technically an approximation because the calculator would be, has many more decimals after it. So I always go back to, if I want to find out the third side, sine of 40 over 4 is equal to, okay, sine of C. Oh, wait a second, what's C? Well, hopefully remember again that a triangle has 180 degrees in it. This one has 60 and 40 already, which means that C is going to be 80 degrees. So that was easy enough to fill out. All over C. I do the same thing. I go ahead and grab my magic calculator, and it's going to tell me that C is equal to 6.128. Great. C is equal to 6.128. Huh. I'm going to point out something really fast. A was the smallest angle. I wonder what was the smallest side. Oh, A was the smallest side. C was the biggest angle. I wonder what the biggest side was. C was the biggest side. Huh. I wonder if that's a trend. We'll find out. What's next? So here we are. Solve this triangle. Okay, so again, I need to see whether or not can I use the law of sines. Here they give me some information up there. Hey, look, I have angle, side, angle. Angle, side, angle is what's given to me. Oh, that's one of the cases, yes, I can use the law of sines. So I'm going to go ahead and use the law of sines. And again, what do I need to know? I need to find out C. I need to find out little a. And I need to find out little b. Again, so what have they already given me? Well, I need to find out C first because these are the pairs I need to put together. So again, adds up to 180, so 35 and 15 is 130 degrees, 50 degrees. So that means there's 130 degrees left over. So now that that's there, I'm going to start with knowing the sine of 130 over 5 is what I'm going to start each of them with. And since we'll go in alphabetical order, we'll do A first. So 35 and goes with the A. So it'd be sine of 35 over A. And now I go ahead and cross multiply and divide. And my magical answer will be A will be equal to 3.743. And so next we go. We do the same thing. We try and find B. All right. So now I have, again, sine of 130 over 5 is equal to sine of 15 over B. And my answer is going to be equal to 1.689. So there are my three answers, 3.743 and 1.689. You may be thinking, wow, this is pretty easy. And you'd be mostly right-ish, because it's now going to get a little bit harder. So let's see how it gets a little bit harder. Okay, so when we get side angle, the ambiguous case, it gets harder. The reason why it gets harder is because if you remember from geometry, the side angle, you could not prove congruent triangles. The reason why you couldn't prove is that there was a possibility that your third side could be one of two values, and that doesn't work out. And so what we need to know is that in order to use sine angle, the law of sines, with sine angle, excuse me, you need to know whether or not it's going to be one triangle, two triangles, or no triangles. And how do I do that? That's a great question. What we do is we come up with a test. And our test is going to be, well, if you give me any side and an angle like this, and for an oblique triangle, I can find out how high my oblique triangle is going to be. Okay, how tall can my oblique triangle be? And that's the height of my oblique triangle. My height will always equal b times sine of alpha. And so if one of the second side that they give me, the A, basically the side that corresponds to my angle they give me, if it's less than h, the height of my triangle, there's no way, here's the height of my triangle, I found out what it was going to be using this formula right here. If this height is taller than A, there's no way that A can reach the bottom. So that's my first test. And it's always going to revolve around h. So you need to know how to find h and how to find sine. Now the h, what I am going to tell you about h is this one thing. H will always be the height. Hang on here, if I can get green. Here we go. H is going to be the height. And instead of B, what I want you to write down is the side given, not across from angle given times, I know that's a lot, I'm sorry, sine of angle given. Don't think of it as A and B. The reason why is because you're not always going to be given A and B. Sometimes it's going to be C or D or X or Y. All right? So that's why I want you to think about it this way. The other cases that follow that you're going to see that are part of these four cases is I could have one right triangle, and that happens when that height is equal to A. Well, that makes sense, right? It drops straight down. The height, because A is also the same as my height of my triangle. And I get two triangles if my A is more than my height. If A is bigger than my height, then I'm going to have two or one. Now, how do I figure that out? Okay. Well, the way I figure that out is that they say here A has to be less than B. Again, this is the part where I need you to translate. A, again, that means the side across from given angle is less than the side across, not across from, not across from given angle. Okay. That one you just have to memorize. Okay, these cases so you have to kind of memorize with. Next one is, okay, I can get one triangle, the last one, I can get one triangle. And the way that I get one triangle, you don't even have to check for H. This is the beauty part of it. If the side across from the given angle is automatically bigger than or equal to B, I have a triangle. There's only one way I can make it. Okay? So let's do this. Take a look at 3 examples. First thing I got to take a look at is I write down something. I make my triangle. So I'm going to make a triangle. I'm going to make it oblique. And they give me a, see here, C is 50. So I'm going to put that as 50. Little c is 1, so that must be that one because it's across from C. And then 2. So to match everything up, I'm going to say this is 2, which means in order for me to solve the triangle, A, B, and this is a little b, I need to find out, hey, they give me angle side side, so I can use the law of sines. All right, but it's angle side side, so before I can go anywhere, I first have to find my height. So let's go first find my height. So I first find my height is equal to the side not across from my given angle, so that means 2, times sine of 50. I go get my magic calculator, and my magic calculator tells me that the answer is 1.532. And I compare that to the side opposite this. That means my height is 1.532. Can 1 reach all the way down? Nope. It can't happen. So since my height is bigger than the little c that's there, since that is true, there is no triangle. So since there's no triangle, I can't possibly solve this triangle. I'm done. Okay? See what's next. This one, they already drew out the triangle for us to show that it is 2 triangles. So let's go ahead and take a look at this one. All right, so again, I draw this out, and I'm not going to draw it that way. I'm going to draw it the way here for right now. I'm going to draw my own. And I'm going to draw my own as being dink, dink, dink. All right. And I say, okay, they give me 35 degrees. Again, I'm just doing this right there. This side, little a, goes with the 35. 6. B, I'm just going to put here. That means that this is big B. This is going to be big C. This is a little c. Again, they give me angle side side, so I need to go ahead and make sure, hey, angle side side means that I need to, I can use the law of sines, but I need to find height first. Again, in order to find the height is equal to the side not across from the angle given to me, in this case 8, times sine of the angle that was given to me of 35 degrees. And I'm going to go find out that that number is equal to 4.589. Huh. Well, I compare that to the side that was given. So if they say here, my height is 4.589. Hey, my h is bigger, or it's not bigger. So you know what? I'm going to have at least one triangle. So then again, next thing I gotta do is I have to compare. Hey, the side across from the given angle, 6, is smaller than the side that's not there. The side that is not across the given angle is 8. Therefore, 2 triangles. How do I find these 2 triangles? And that's where it's going to take a little bit of effort. Okay? So let's do the first one. All right, so first thing I'm going to do is I come over here and say, well, I'm going to set up a little thing. I know that sine of 35 over 6 is going to equal sine of b over 8. I do my cross multiply and divide. This time what I find out is that sine of b is equal to sine of 35. Gives me 8 times sine of 35 divided by 6. But my other problem now is this, that I don't want just sine of b, I want b. So I need to undo that by doing arc sine. So b is equal to the inverse sine of this big giant mess. And then I take that and I put it in the calculator to find out what b is. And that's going to give me b equal to 50. Now if you're doing this at home, okay, it's not going to be exactly 50, but for the sake of argument, I'm going to make life easy. I'm going to say 50 degrees. Okay, great. So b is 50 degrees. I'm happy with that. And then from there, I can go ahead and find out what big C is, right? Because I have 35. Big C, I have 35. And so C is equal to 180 minus the 35 minus that 50 I just got, which is then going to be equal to 95 degrees. And I'm going to leave it up for you to find little c, okay, because this video is getting kind of long. But the question becomes, how would I go about finding my second triangle? Where does that come from? And it comes from the fact that our unit circle, okay, sine is positive both in quadrant 1, which is what arc sine finds for us, but it's also positive in quadrant 2, which arc sine doesn't find. Why? Because it's not part of the domain. So in order to find out where the other possibility is for that second b, to find my other b, I'll call it b2. I take the b1, or I take 180, and I subtract it from b1, which is the first one we did. And that's going to be, and this is important, you need to write that part down. Highlight it, circle it. So it means that b2 is equal to 180 minus 50, which is equal to 130. And therefore then c, my c2, is now equal to the 180 degrees in a triangle minus the 35 minus my new 130. So 130 and 35, that's 65. I subtract all that. That is equal to 15 degrees is what's left over. Again, I'm going to leave that to you to find the third C using the law of sines. To set that up for both of these, this would end up being the same thing we started with here. Sine of 35 over 6 is equal to sine of 95 over C. Cross multiply, divide. And then this one over here would be sine of 35 over 6 is equal to now sine of 15 over C. And you can find out both the C's. All right. Yeah, I know, it's a lot. All right. We're almost there. Got one more example to do, and then we're going to call it quits, I believe. We're going to solve this triangle. Or it's one solution. I hope it's one solution. All right. I'm telling you it's one solution. So I go through the same rigmarole. But this time I go, here we go. I see here that I make my own triangle. Again, I make my own because I want you to have practice at doing this too. They give me this is 40 degrees. That was big A, so that means little a is 3. And B on this one is 2. That means that this is big B. This is big C. This is little c. And I go, hey, okay, so this is angle, side, side. So yes, I use the law of sines, but I do have to check the h, the height. But then I remember, wait a second. If the side opposite here, okay, of the angle, which is 3, it's bigger than the side that wasn't giving me 2. Bigger than or equal to, check. That's true. Therefore, only one triangle. And this is where you celebrate. You don't have to worry about it. There's no real ambiguous case. We already figured that out. Boom. So we don't have to find h, which is even better. Yay! So let's just get to it. Now we pick an angle we want. We want to use the sine of 40 over 3 since that's what's given to us. Let's start off with b because it gives us a piece of b over 2 sine of b. I go cross multiply and divide. I find out that sine of b is equal to 2 times sine of 40 all divided by 3. Inverse sine, both sides. You get b is equal to sine inverse of 2 sine 40 all over 3. You put that into the magic calculator, we find out what it's going to give us. Which is equal to 25.373. I'm just going to say 25 degrees, just to make life easy again. And so then when I go and find C is going to be equal to 40. This is big C. Not 40. 180 minus 180 minus a 40 minus a 25, which is then equal to 125? No. 65, 115. 115 degrees. Great. And from there, I set up the last one to find out C, because there's that C. Alright, there's B. So the third piece I need to find is little c. So again, I set with sine of 40 divided by 3 is equal to sine of 115 divided by little c. I go get my happy calculator, and it's going to tell me that the answer is C is equal to 4.229. So again, I want to take a look here and show you and clarify this 100%. Notice again, largest angle was C, largest side was C, smallest angle was B, smallest side was B. Will always happen. You cool. Alright, I'm going to call it quits. We're at a way too long of a point. We'll take care of the other ones on the second one Tuesday night. I'll talk to you guys later. Bye.